So today we will continue with the mathematical operations with radicals. We will start with multiplication. We will divide the multiplication in 3 different videos. Today we are going to see the multiplication when radicals have exactly the same index. So in this case, to be possible to multiply radicals, they must be converted in order to have the same index. But in this case, it's not like in addition and subtraction, because in addition and subtraction, they must have it. In this case, we can convert it in order to have the same index. We will start today with the basics. We will start today to see how to multiply radicals when they have the same index. So when they have the same index, it's very simple. We only need to put all the radicals on the same one because it's a multiplication. So we will multiply all the radicals because they have the same index. We can put them inside a same radical. We will multiply the algebraic expressions, and we will be able to simplify something inside the radical, or maybe we can take out something from the radical. It's possible. So that will be multiplication of radicals with the same index. Let's see some examples. So here we have the first exercise. The fifth root of this one multiplied by the fifth root of this one. So it's going to be very simple because we will multiply this expression by this expression and we will have it in a single fifth root. Of course, maybe we can like multiply the 16 times 8 and we will have a super big number, and then we can decompose it. Or maybe we can decompose both before multiplying. So if we decompose it before multiplying, the 16, it's going to be 2 to the 4 x cubed y. The 8, it's going to be 2 cubed x squared y cubed, if I put it in order. So now we can put it in a single radical, that it's going to be a fifth radical. 2 to the 4 that multiplies 2 to the third. Remember, when we multiply, the powers get added. 4 plus 3, it's going to be 2 to the 7. Then the letter is going to be exactly the same. X cubed, x squared. It's going to be 3 and 2, it's 5. Y and y cubed. It's going to be y to the 4. So after doing this one, we need to check out if it's possible to take out something from the radical. Of course, the 2 can go out and the x can go out because they have a number that it's at least the same number as the index. The y will stay inside because it's a smaller number than the index. So it's going to be, I can take out 7 divided by 5, it's 1. And in the inside part, of course, we will still have 2 of them. In the case of x, we can take it out, and it's going to be only 1 outside, 0 inside, because 5 divided by 5 is an exact division. Y to the 4th will stay inside, so our answer is going to be 2x that multiplies the fifth root. 2 squared is 4, y to the 4. And this is going to be the final answer. So as I was telling you, the idea is very simple. We will multiply both, or if we have 3 of them, all the expressions to convert it into a single radical. And after having a single radical, we can simplify it and taking out something from the radicals, and that's going to be all the process for multiplication of radicals with the same index. Let's see other example. So let's see this exercise. First, we have an odd power of a negative one, so we can take out the sign so before doing anything. So it's going to be 2a that multiplies the cubic root of 81a squared b to the 5 if we put it in order. Minus multiplied by minus is going to be plus, so it's going to be 3b that multiplies the cubic root of 125 a squared b. So after that, we can decompose the numbers inside the root, and it's going to be 81. It's 3 times 3 times 3 times 3. So it's going to be 3 to the 4. A squared b to the 5. On the other one, it's going to be 3b that multiplies. Here it's going to be 5 times 5, 25 times 5, it's 125. So it's going to be 5 cubed a squared b. So what happens here? Of course, maybe we can like put this one and this one in the same one, and the coefficient of this one and the coefficient of this one will multiply. So it's going to be, we can multiply outside the radicals. 3 times 2 is 6ab. That's the coefficients outside the radical. In the inside part, it's going to be 3 to the 4. That multiplies 5 cubed. A squared and a squared is going to be a to the 4. B to the 5 and b to the 1 is going to be b to the 6. So after that one, of course, the 6ab stays outside. That will multiply whatever we take out of the root. The 3 can go outside 1. The 5 can go outside 1 also. The a can go outside 1. The v can go outside 2 because 6 divided by 3 it's exactly 2. In the inside part we still have 1 3 because it's not a 4 divided by 3, it's not an exact division. 4 divided by 3 it's not also, and so we have also an a. So it's going to be, if we multiply 5 times 3, it's 15 times 6. So let's see, 15 times 6, it's going to be 90. So it's going to be 90. What about the letters? We have a and a, it's going to be a squared. We have b and b squared, so it's going to be b to the third. That multiplies the cubic root of 3a. And this one, it's going to be my final answer. So the idea for all the exercises is basically the same. We will multiply what it's the coefficients that are the outside part of the radical between them. We will put all the radicals in the same one. We will take out what is possible to take out and simplify to have our final answer. Let's see other exercise. So in this one, first, we will need to decompose the 15 and the 75. So it's going to be minus 3 over 5. The 15, it's only 3 times 5. The other one is going to be 1, 9. The 75, let's see, 75 divided by 3, it's 25. Divided by 5, it's 5. Divided by 5, it's 1. So this one is going to be 3. That multiplies 5 squared. So let's see. It's going to be minus 3 over 5. That multiplies 1 over 9. 9, it's 3 times 3. Because we will multiply this coefficient and this coefficient. So it's going to be, of course, it's going to be negative. Minus multiplied by plus, it's negative. It's going to be this 3 with this 3. So it's going to be 1 over 15. So it's going to be 1 over 15. In the inside part, it's going to be 3 and 3. It's 3 squared. 5 and 5 squared. It's 5 to the third. So what will happen here? Minus 1 over 15. That multiplies. It's going to be, we can take out a 3. We can take out a 5. And on the inside part, because the 3 divided by 2, it's not an exact division, we will still have a 5. So here we will have minus 15 divided by 15. That multiplies the square root of 5. Minus 15 divided by 15, it's going to be only minus 1. Remember, we don't need to put the minus 1. I will put it here only for explanation purposes. So our final answer is going to be only minus the square root of 5. So the idea is basically the same. We will multiply the coefficients, we will multiply the roots, and we will take out whatever we can take out of the root, and we will simplify our final answer. So let's see other example. So let's see. In this specific exercise, we have odd powers, the cubic roots of negatives. So maybe we can take the sign in order to not forget that part. So it's going to be minus multiplied by minus, going to be plus 8y divided by 3x to the 5, the cubic root of 54 x squared y. All of it that multiplies, I'm sorry, I forgot the minus. Here it's going to be the minus cubic root of 8 x cubed y. So after that we can decompose the numbers. So it's going to be 8y divided by 3x to the 5, the cubic root. If we decompose the 54, 2, it's going to be 27, 3 it's 9, 3 it's 3, 3 it's 1. So this one is going to be 2 that multiplies 3 cubed x squared y. That multiplies minus the cubic root 8, it's 2 cubed x cubed y. So on this one, of course, it's going to be negative 8y over 3x to the 5. This one will multiply 2 and 2 cubed. It's going to be 2 to the 4. That multiplies 3 cubed x squared, x to the 3, it's x to the 5, y and y, it's going to be y squared. So after this one, we need to check what we can take out of the root. So it's going to be minus 8y divided by 3x to the 5. That multiplies, and let's see, of course, everything will go on the upper part because we don't have fraction in the radical. So we can take out a number 2, we can take out a number 3, we can take out an x. And it's going to be all of it multiplied by the cubic root. What it's inside, of course, there is a 2 because 4 divided by 3, it's not an exact root. I mean an exact division. 3 divided by 3, it's an exact division. 5 divided by 3, so we still have x squared on the inside part. And we have also y squared because the 2 is smaller than the 3, so it cannot go out. So it's going to be, in this case, it's going to be, of course, these 3 with these 3 can get eliminated. X to the 5 and x, it's going to be only, well, it's going to be negative, the answer. 8 times 2, it's 16. X and x to the 5 is going to be x to the 4 on the bottom part. Y, we only have it on top. That multiplies the cubic root of 2x squared y squared. And this one is going to be our final answer. So as always, the idea is to multiply the coefficients, what it's outside the radical, then the radicals put it in a single radical, take out whatever it's possible to take out, and simplify our answer. So let's see one last example. So let's see in this exercise. So in this exercise, it's going to be exactly the same. We can decompose the radicals. So 32, it's 2 times 2 times 2 times 2, 5 times. So it's going to be 2 to the 5, 8 to the 5x divided by 3b to the 5, y to the 4. This one multiplies 1/2. We can decompose it and it's going to be 3 cubed. If we put it in order, b to the 4y. 8, it's 2 times 2 times 2, so 2 cubed, ax. That multiplies minus 12x, the square root of 3 divided by 2 squared. So after this one, we can multiply, in this case, the coefficients that are 3, that multiplies 1/2, that multiplies minus 12x. So it's going to be 12 divided by 2, it's 6 times 3. is going to be minus 18x. So it's going to be minus 18x that multiplies, and let's see what happens on top, what happens on the bottom. On top we have 2 to the 5, 3 cubed and 3, it's going to be 3 to the 4. Then we have a to the 5, b to the 4, x and y. And on the denominator part, we will have 2 cubed and 2 squared. It's going to be 2 to the 5. That multiplies 3. In the case of the letters, we have a, we have b to the 5, we have x, and we have y to the 4. So what will happen before taking out something from the root? Maybe we can simplify it, and it's going to be, let's see, 2 to the 5 and 2 to the 5, 3 to the 4 and 3, it's going to be 3 to the 3 on top. Then it's going to be a to the 5 and a, it's going to be a to the 4 on top. B to the 4 and b to the 5 is going to be only b on the bottom part. X and x will disappear. Y to the 4 and y is going to be y to the 3rd. So after this one, we can take out something from the roots, and it's going to be minus 18x that multiplies. On top, it's possible to take out a 3. It's possible to take out a squared. On the bottom, it's possible to take out a y. All of it that multiplies. What's inside? It's inside a 3 because it's not an exact division. And it's also a b and a y. So in this one, it's going to be, if we multiply this one that has a 1, it's going to be minus 18 times 3, it's 54, a squared x, all of it divided by y, that multiplies the square root of 3 divided by by. And this one is going to be our final answer. So the idea is basically the same on all the exercises. The idea is we will multiply the coefficients. We will put all the radicals in a single radical. Then we will simplify it, take it out what it's possible to take it out, and that will be our final answer. So we will see each other for the next video, that it will be also about radical multiplication with compound radicals.